Everyone, welcome to the Global Chess Challenge live workshop event. In today's event, we'll go through some of the feedback and queries that we have received from participants during the course of the challenge and try to respond to them. Alongside it, we also have a really exciting workshop by Jim Burtoft. This is a version of the workshop that he conducted at Neurips this year. Jim, let's learn a little bit more about the speaker today. Jim Burtoft is a generative AI specialist, part of Amazon Web Services. He has a background in mathematics and he has worked in machine learning and security for over 15 years. He's focused on AWS custom AI chips like Trainium and how to use them in different ML frameworks. Alongside Jim, we also have Alexa Orent, who's the head of community and strategic partnership at AGI House. Alexa builds partnerships and helps run interesting builder-focused events and hackathons for AI community. She's based in Bay Area and a Cornell University alum. I just want to make a quick note that the environment that Jim is giving a walkthrough for was only open for the 1 hour duration of the live workshop. So if you're watching a recording of this, you will unfortunately not have access to it, but we encourage you to take away some learnings from the video and try to implement a version of it for your solutions. All the best. We're looking forward to seeing your exciting solutions. Certain updates on challenge timeline and final evaluation will be communicated soon to you over email and over community forum. All the best.
And all we're doing here is that we have created we've set up a Trainium 2 instance. We've made sure that we have the security rules in place. We have then cloned the Neuron workshops from GitHub, and we're going to run through. There's a lot of other code in here for Trainium. You're welcome to play around with that. The two that were used for the chess is, first of all, the underneath fine-tuning, 0-1 fine-tuning. We have an FT Quen 3 chess. This takes us through fine-tuning the model. And then the other thing that we can do is here under VLLM, we have a chess folder, and this will be the deployment. So for today, what I'd like to do is I will walk through the fine-tuning notebook, but I want to focus on the chess deployment. So I'm going to start here on the chess deployment, and I'm going to kick off some installs because it does need to download the model. So if you want to follow along with me under VLLM, you can go to chess, and we're going to be using the chess deployment. We're not going to use Trainium 2. We're running on a Trainium 1 instance, so we're going to stick with this main chess deployment. And we start with installing the dependencies, so we can click play here. It's going to ask you about the kernel source. So we want to choose a Python environment, and then the one on the bottom here is the virtual environment, this AWS Neuron X VENV PyTorch latest. That already has some of these installed. If you want to take a look, we can see inside of the requirements, we're installing Python Chess, we're installing Stockfish, a few other things here. One of the other big ones that we're installing is Optimum Neuron. This is a library that we have. Let me walk you through this. You know what? I'm going to hold off on that until we get to the next step. So I'll walk you through the Neuron developer stack. But we've got a couple things, specifically the deployment that's going to download a pre-trained model and deploy that. That takes a little bit of time. So once we get to that part of the workbook, I'll hop over and explain a little bit more what we're doing. Yeah. So while that's running, we've got a couple parts of the developer stack. So we've got, we're using PyTorch. Right now, we have our own version of PyTorch called Torch Neuron X. We announced at reInvent, which is our big conference, first week of December, we announced that we are supporting native PyTorch integration. So that's coming in Q1. So a lot of these things that we've had to do to kind of work with our version of Torch, we won't need to do in the next quarter. So we finished that set of installs. We're going to install one more component. Let that run. So we've got Torch Neuron X. On top of that, we've got, you might see a Neuron X distributed. That is our model library, if you would, and it handles the parallelization. So each of our Trainium devices has 16 gigs of RAM available to it because these are Trainium 1. So we need to parallelize a model once we start to fill up that amount of RAM. And for some of the smaller models, you might need to parallelize a little earlier than you would on a large GPU. So we provide that Neuron X distributed that handles the parallelization for us. You can see on this particular instance, it's a TRN1 2x large, and it has one neuron device, index 0, and on that there are 2 cores. And so everything that we're doing here, you're going to see a tensor parallelism of 2. I'm going to run this next cell just to configure the model path. And you'll see we got an error or a note that there was no model found because we did not go through the fine-tuning process, but we're going to use the pre-compiled model, which is right here, and it's available up on Hugging Face. And then we will start the VLLM server. So kick that off and then come down here to this bash, and that's going to start up the VLLM server, and we'll be able to watch it from this log. That's going to take a little while because as part of that startup, it is downloading that pre-configured model. So I'm going to wait for a minute. We're going to hop back and see if we have any questions. At this point, if you have any questions, feel free to come off mute and just ask. We'll let that run, and I will talk a little bit about the developer stack. So we've talked a little bit about these Trainium devices, and these are custom AI chips developed from the ground up by AWS. So these are not drop-in replacements for a GPU. It's an entirely different architecture that has been designed to be optimized for AI, specifically matrix multiplication. That's one of the big things that we do inside of the hardware. So that gives us a lot of advantages. So when you're thinking about using Trainium, you want to think about those use cases of as this model doing or able to do a lot of matrix multiplication. Because if not, then you might want to be looking at a different type of accelerator. Fortunately, the large language models, especially the transformer-based ones, inside are doing a lot of matrix multiplication, so that works out well. And we are letting you take advantage of that by integrating in the libraries at a couple different levels. So we have VLLM integration. So we've just done a native VLLM integration as well. If you've seen in the documentation in the past, we would install a special version of VLLM. In this particular set, we installed VLLM using the Hugging Face library. So Hugging Face partners with us on the Optimum Neuron library. So this is a library that runs on top of the base SDK. It's part of the Neuron developer stack, and it lets you use a lot of the Hugging Face APIs and libraries. So if you look at the fine-tuning version, we're using TRL. From Hugging Face, we're using Accelerate, a lot of those other libraries that Hugging Face kind of integrates for us. And it takes care of that transparently. So as long as you're using one of these supported models, you should be able to run that training and inference, and Hugging Face will manage that. We've also got integrations with a couple of different orchestrations environments like EKS for Kubernetes, Ray, and then we also integrate at the frameworks level. So if you're using JAX or PyTorch, we now have those native integrations where you can run your JAX code on Trainium Also with the PyTorch native, which is available as a restricted beta right now, but it'll be general in Q1. That lets you run your regular PyTorch code with just device equals neuron. If that's something that you're interested in playing around with, feel free to reach out to me. Or if you can't get in touch with me, you can reach out through Alexa and she can coordinate with me and we can try to get you that beta access to give you that native PyTorch integration. Along with that, then comes all of these libraries and APIs that are running on top of PyTorch, like FSDP, and then we're also integrating with some of those other orchestration tools. So I'm going to flip back to here, and we're going to take a look at this log and see how we're doing. If you've noticed that log isn't being updated, it's because it's running something in the background and it just hasn't updated yet. So from this bash prompt on another tab, I can allow my paste. Yep. And so we can see at this point, it is fetching some files. I think it still has another couple files to fetch. If you come back from the notebook, if you run the next cell, which is waiting for this to come up, we can test that connection. Right now, it should come back as not available because VLLM has not opened that port because it's still downloading the model. All right. I'm going to stop again and see if we have any questions or comments. So the workshop environment. So the workshop environment right now is public. Anybody with that URL and that access code can access it. It's only going to be available for the next hour. The notebooks that we're running are available on GitHub all the time. You would just need to download them and run them in your environment. And if you need to do that, I have another link that I will give you, because you will need to do a few things like requesting the service quota. All right, so I posted, we've got a couple articles on repost and, we got the YouTube. Yes, we'll share the Git repo link. So there's another thing that'll walk you through how to set up Trainium in your environment. And there is the GitHub repo. Let's see how we're doing in our environment. Share my screen. Okay, it's still downloading. This is something where if you were watching this in the console, you could see those bars creeping across because we're just dumping it to a log file. We're not going to see that until it finishes. All right. Any questions? Any other questions so far? All right. While we were waiting for that, I'm going to hop back and we'll walk through the fine-tuning notebook. This is something that you can run on your own in this environment. The only thing we have to watch is we only have 2 neuron cores. And so the training process will use 2 of them, or we're set up for inference to use 2 of them. So while you can do both, you can only do one at a time. But if we go back, we can take a look at this fine tuning. So a little bit about the data set. We've got another set of requirements that we install. Most of these are going to be pretty close to what we already did, but you can see we're installing Optimum Neuron, like we mentioned, PEFT, TRL, and data sets. And I'm going to open up this FT Quen chess. So essentially, after we install those requirements, we kick off this torch run. We've got one node, two processes per node, and we're using this fine-tuned chess model.py. We'll go back through that in a minute. And we are using LoRa fine-tuning, so you can see we've got our LoRa parameters here. And after we run that fine-tuning and the model finishes, we do a consolidation as part of the model training script at the end. And then because this is a new model, we do a compilation. So compilation is something that you'll see a couple different times on Inferentia and Trainium. This is where we are taking that model and we're figuring out the computational graph so that we can load it and run it efficiently on the device. If you are familiar with Torch Compile from on GPUs, this is something similar. You can see we're compiling it with a sequence length of 2048 and a batch size of 4. So that lets us use the Trainium device to process 4 requests at a time. That's nice when we're doing the tournament, if we're running multiple games at a time, like you see in the notebook. And then we just run through an example of inference. We're going to see this in the other notebook as well. But let's hop in and take a look at what we're doing here. And let's see. And we're still downloading. But you can see inside of the assets folder, we have a fine-tuned chess model. So like I said, we've got other code in here. So this fine-tuned chess model is actually based on some other fine-tuned examples that we have where we did like our text to SQL. We've got a notebook in here that uses Llama. This one is using Quen, but it's the same fine-tuned script. It's just passing a different model. In the chess model here, we're using a different query template. So if we scroll through this, and again, if you're looking, it's under fine-tuning assets and the fine-tuned chess model. The first thing we're doing is just setting up that conversation template. And we're grabbing the data set. This data set is the one that AI Crowd put together. So you can see that here in the Chess Explained. So we've got, we set up the messages, we define the data set, we define our training config. We got a couple options in here. We're not using flash attention because in this case, we are using a smaller sequence length. And you'll notice in a couple places that we do this where we're using a small model, we're using a small sequence length. This is because we're doing this in the workshop environment and we expect to be able to finish these tasks inside of 30 minutes or so. So we have to keep those limited. Obviously, in your environment, you can change some of these modules or some of these options. We grab the LoRa config that we pass in from the torch run command. We have our SFT config. If you're familiar with the Hugging Face libraries, you might know SFT config. So we're using the Neuron SFT config. It basically takes the same arguments as SFT config, but it adds in a few of the extra ones that we need for the Neuron training. And just like in another Hugging Face training script, instead of using SFT trainer, we're using the Neuron SFT trainer. We're passing those configurations in, and then we just do trainer train. We can take a look at sorry, it looks like we deleted the output. I have that over here. All right, cleaned it up. But so that's the fine tuning. And again, we're not going through that just because of time today, but you do have that output available. I will leave this environment open for 30 minutes past the end of this call. So if you want to go back and run through the fine-tuning notebook, you'll have time to do that. And we can see back here on our prompt that we've gone through, downloaded the 8 files, and it is starting to load that model from disk now. All right, I'm going to pause again. See if we've got any questions. All right, we got a question from Mahanti. Okay, Mahanti, I see some questions about the model size limit. And model types.
To answer the question about the model which is accidentally resigning, once we are just rolling out that fix, after that the actual ACPL for that model will be really low, because we will be penalizing that resignation with a high CPL score. So you won't have to do anything specifically. You can just submit your model, and then the current scores for your model will just go up actually in this case.
Right. And questions on the size limit of the model?
Yes, 8B models are the limit. And I think, again, I was just asking it internally. Someone tried to submit GPT-OSS 20B models, which also didn't work. But then anyway, not supported at this point. But when we run the tournament, anything beyond the 8B limit will be removed anyway. But thanks for bringing that. Just double check it once.
Yep. And then the chain of thought or reasoning techniques.
Yeah, that's perfectly fine. It's you are encouraged to kind of use COT or reasoning techniques, as long as you can stick to the timeouts and your model actually responds with the correct UCM of tags.
All right. Any other questions? All right. I'll back. All right. So at this point, and again, I am looking in my bash prompt tab. I just ran a tail on the log file. We can see that it finally finished grabbing those 8 files, the weights from Hugging Face. You'll see a couple notes here from the Neuron X distributed. I mentioned that as a library that we're using starting up. And then we've got the VLLM starting up here. And you can tell when you see at the bottom, info started. If we come back to the chess deployment notebook, I ran this cell earlier and I got a connection failed. If I run it now, we should get a connection ready. Yep. So it says VLLM server is running. Excuse me. We got a test response. I'm going to exit out of that. If you want to see what it's doing on the back end, you can use neuron-top. It looks a little funny in the web page here, but at the top we've got our neuron core devices, our ND0, and our that's neuron device 0 with neuron core 0 and neuron core 1. If I use my right arrow, I can expand the neuron core. I can see that I'm using 18 gigs of device memory on the device. That's 9 gigs per core. And you can scroll down and see 2 different nefs. One of those is going to be for context encoding. The other one is going to be for token generation. So these are those computational graphs that I mentioned we get from compiling. And then, of course, we've got a bunch of tensors in here for the model weights. And then we've got the same thing on the other core. So I'm going to hit Q to get out of that. Okay, so back here under deployment, now that the server's ready, we can test that model against Stockfish. I'm going to use the settings in the environment example. So we're using that VLLM model. Remember that VLLM model is part of the query that it's sending. So if you're changing your model name, you would need to change that, but I'm going to keep it. So copy those environments over, make that environment part of this notebook. Make sure I can see the VLLM model, and then we can come down here and start running some games. And so then this is taking advantage of all of the tools that we have here in the toolkit. You can see playing some. Let's take a little example. We've got, yep. So there's the output from the model. Now, keep in mind, in this case, we can look in the prompt and we'll see that it's just asking for the output. It's not doing a lot of reasoning. And the reason for that is because we want to make sure that it's able to complete within that budget of tokens that we've given it, which is, I think, 2K on here. So we're trying to keep that down. Obviously, having the model reason is part of what you would be doing as part of that, but you can see we went through this, didn't make any illegal moves. We can do another performance validation. You can see we're pretty consistent. We talked a little bit about the concurrency benefits, where if we compile it for a batch size of 4, that comes in over here if we're doing the chess tournament. So just like before, so now I've moved over to another notebook. So from chess deployment to chess tournament. So we're going to make sure that we are, the VLLM server is running. Remember, I need to choose that kernel. I want to make sure I'm using that Neuron X VENV PyTorch latest. And in this chess deployment notebook, I deployed it as an API endpoint. So that's going to keep running, even though it's not in the notebook. If you are going to go back and run that fine-tuning notebook, make sure you kill that VLLM process. Again, we're going to add those environment variables. Print it out. We can play a single game. So we're using the run game script from here inside of assets. Got the initial position. You can see it's going through here. If you have trouble reading that, you can make sure you view as a scrollable element. And that'll let you go back up through. You can see the statistics here at the end. And we can also run a tournament. So right now we're using a parallelism of 1, which means we're sending 1 request at a time. We can watch that go through with the different moves. And then we'll come back later on and do that with a concurrency of 4. And what that does is just kind of demonstrate the difference in speed, because even though we're doing the same number of requests, we are going to get through it faster with a parallelism of 4. And then we'll have the ability to run the full tournament and go through the analysis. So I'm going to pause here, because I think we've seen the interesting bits. We'll finish going through the notebook. So we ran through that. It took 53 seconds, and we'll run it with concurrency. So we're running multiple games at the same time. If I can get the Yeah, so if you look at the top, I don't know if you saw it, we'll come back. We can see those little bar graphs hopping up for the utilization, but it looks like we finished. Okay, so it took 53 seconds with a parallelism of 1. It took 40 seconds with a parallelism of 4. So not 4 times faster because we're still limited by the processing on the device, but this is something that you can tune when you're running in parallel. So now we can run a full tournament. And if I hop back to Bash and run Neuron top, you can see at the top, I've got my 2 Neuron devices, and it shows the percentage of utilization between 50%, 90%. If I hit F, you can actually see the number of teraflops that it's executing. Q to exit out of that. All right, we're doing 20 games. Any questions? Feel free to come off mute. Check. All right, I see it coming from Jyotish that we also have a max token budget of 2,000. So Jyotish, you're saying in the evaluation, we give you 2,000. All right, so we've gone through the tournament with a couple different agents. So we used the VLLM agent against a couple stockfish with different depths. We've got our results saved out. We'll go through and do that analysis. So you can see even with a skill depth of 15, that wins all the time. Interesting with a skill depth of 2, we saw 50-50, and of course our VLLM gets 0. And keep in mind, this is a small model. We did do some fine tuning for it, so it answers successfully, but it's still not making great decisions, at least not compared to stockfish. And then, of course, we can do a little bit more detailed metrics, but when we play 7 games and we lose them all, there isn't a lot to look at. All right, I think we've got some of the concurrency metrics that we had gathered earlier. Yeah, I think that takes us through the notebooks. So I'm going to pause here. Like I said, we're not going to run through the fine-tuning notebook here, but I will leave this environment up for at least the next 30 minutes. So if you are in it and you're running through, feel free to keep doing that. The other thing to remember is that these workshop environments do go away. So if you are doing anything or making changes or putting in any code, you're welcome to test that out in this environment. Just make sure that you download it, because once these go away, they're gone. And Tanisha, anything else from our side? Looks like we have all the questions answered.
I guess that's it. Do we have any more questions before we close this call? All right. If not, then I guess this is the end of the event. Thank you so much, Jim, for the walkthrough. And thank you, Alexa. Thank you, Mohanty, for answering the questions. And most importantly, thank you to all the participants who joined this and shared your feedback on the challenge. And as mentioned by Mohanty, there are certain things that we are internally figuring out, and we share an update about those very soon, and they'll be communicated to you on the forum, over the emails. And yes, all the best, keep submitting, and hope to see you all on the leaderboard.
Yeah.
Bye.
Thanks, everybody. We appreciate your efforts.